Starting to play with some electronics that you can actually directly plug into the wall to get power. That's extremely nice, but also extremely dangerous as far as you get 220 volt directly into your electronics, which makes it difficult to debug and troubleshoot the electronics itself, and also meaning that touching the wrong cable would certainly kill you. So I had to build my own security system to avoid dying for now. I could not find much information on the internet, so I'm gonna show you here what I built. First of all, some disclaimer: I am in no way an electrician. I am not licensed in any way, shape or form, and before doing anything on your side, you should definitely consult an electrician based on your country and such. If you're going to put 220 volt into one of your devices, I see mainly two issues. First of all, you could start a fire. That one would be because of a short circuit or something like that that creates a lot of current inside of the device itself, and that would create a lot of heat, or maybe you could have some sparks starting a fire somewhere next to it or on the electronic itself. Secondly, you could actually touch the wrong cable, which would make the electricity go through your body and actually burning you from the inside, which is suboptimal. Your heart is not going to survive if the electricity goes through it. The issue is that technically you are always connected to the earth, and the earth is a perfectly valid return path for the current. So if you touch the line, then you become part of the return path that is perfectly valid. You might be wondering, why the fuck is the earth a perfectly fine return path for the current? That should be the neutral. And actually, as it turns out, the way the electric grid is built in most countries, the neutral and the earth are connected together at the transformer level. That is a security feature for within the house. For example, inside of a house, you're going to have your washing machine that's going to have its line and neutral to make the motor turn and such. And you're going to have the outer case of the washing machine that is metal, that usually you're going to connect to the earth. The main characteristic is that if somebody touches the outer shell of the washing machine, you don't want that person to get electrocuted. So the way to do that is to actually connect the earth to the neutral. That way, if a line cable somehow starts touching the outer shell, it's going to create a short and it's going to start triggering some securities, and so that the electricity is going to be cut before anybody can actually touch the outer shell and get electrocuted. Regarding the first issue, aka the fires, you can first start by not putting anything flammable next to your device. That means, for example, don't put your device on a cardboard. Second of all, just be ready if there is an issue. Be quick to cut the electricity and always get a fire extinguisher at hand that is actually rated for electric fire. Regarding the second issue, aka getting electricity through your body, the first common advice that is given is to actually always keep one hand behind your back and test with only one hand. That's a good start, but still, if you touch the wrong cable with your hand, you're still gonna get burned. So we're gonna see how to build a device that should protect us, hopefully, in such a case. Another common sense advice would be to actually never try on your own in the dark, alone, with nobody knowing about you. Lonely. Do have somebody close by to actually make sure that you're still alive at the end of your tests. That would be a good first start. To get a little further and actually build some proper security for us, we can rely on the security that is already inside our house. If you have any, depending on your country, it might not. Where I am here right now, for example, there is no security if I touch the wires in the wall. So we're gonna have to build our own. So that is gonna be just a circuit breaker that we will have to design ourselves. In such a circuit breaker, we're gonna have two types of circuit breaker that are gonna be useful for our two different types of issues. Let's see then. So first of all, we're going to have those small circuit breakers that are the very much standard. This one is a C10, that means that it's going to cut at 10 amps. That one is extremely dumb. Just if there is more than 10 amps, it cuts and that's it. That's going to be great to prevent fires. If there is a short circuit in your electronics, then that one is going to cut it, and hopefully before anything becomes bad. The second type of circuit breaker is going to be that one, an RCBO, which is going to be a little bit more advanced and a little bit a lot more expensive. But this one is also C10, so it's also going to cut at more than 10 amps if those 10 amps goes into your circuit, but also it's going to cut at 30 milliamps if that current goes out of where it should be. By the current going not where it's supposed to be, the way that RCBO works is that it's going to measure the current going through the line and coming back through the neutral, and it's going to measure the difference between those two. If the difference of current is 0, then that means that all the current going out through the line is coming back through the neutral, so everything is fine. In the case if somebody is touching the line cable, for example somewhere else, that person is going to become part of the circuit, and that current is going to go to the earth and so not be coming back through the neutral. So there you're going to have a difference. If the difference is greater than 30 milliamp, that one cuts. In that case, I got a 30 milliamps. That is the only one that I could find where I am. You got some smaller version for 20 milliamp and 10 milliamp. I think that the smaller the better in our case. That limit of 30 milliamp is defined by the limit of what the current the human body is able to sustain without actually dying. As you can see on that graphic, the lower the better. The less current you get through your body, the more chances you have to survive. That's why in our case 30 milliamp might be a little bit overkill and would be safer to actually get a lower rating, because we are only testing one electronic device, so there is not going to be that many leakage that would come from somewhere else. It's only security in our case, so the lower the better. So in that case, in that precise wiring, I'm using the Schneider system because that's the one that I got available around here and I tend to trust them. As far as I'm trying not to die, finding a brand that to trust is certainly a good idea. The way it works is that you're going to have some small holes here that you can punch out. You just have to put a lot of strength into it to actually cut them out, but they're already pre-cut, so you need to put some force, but it should be okay. You can pass a wire through. That wire is then going to have the earth bar here, and we're going to have to inject it into one of those MCB circuit breakers that are going to be your main circuit breaker. You have to have one of those with that Schneider system. I didn't find any other way of making a clean connection. We don't really need it in our special unique case for testing electronic, but that makes things cleaner. So you're going to have the input going here and here for neutral and line as precised inside the box, and that is going to actually feed our line and neutral inside of the bars that are inside of the plastic of the box, and then each one of our circuit breaker can plug in and using those tabs get fitted the line and neutral for each one of them. The regular circuit breaker doesn't need any other wires anywhere or nothing apart from the output of it. The RCBO itself needs a little bit more wiring because you need to measure the differential. So you're going to have the line out, the neutral out, and you need to add another neutral that goes onto the neutral bar here. After that, you just got to wire the earth line out, neutral out from the RCBO to your plug that you want to use to connect your electronics, and you should be good to go. Every time you start it up, you're going to have to turn on the MCB, turn on the RCBO, and you can test it. Here it's not going to trigger because we are not connected in any way. Do not do those kind of modification with the system under power. Well, that's it. I hope those advices and experiences that I had may help you to test your electronics in a safer manner. If yourself you have a better solution, or especially a more compact one, that thing, I would love to hear about it. Please leave it in the comment. I would love to improve that system because damn, it is way too big. Thank you. Yeah. Do 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 do. Do do.